All right, so we're looking at determining slope, and we've got 2 points in both of these cases here, so we'll just look at the examples. I'm just going to label, these are 2 points, and I'm just going to call the first one 1 and the second one 2. So I will label this one x1, y1, okay? Let me fix that there. Kind of did something funny there. And the next one, just label x2, y2. Now it doesn't really matter which one I label 1 and 2. And then I can determine the slope, and really the slope is rise over run. So if we looked at number 1, rise over run. And rise is the change in the y value. How do we get that? Well, we take the difference between the two y values, y2 minus y1. That's gonna, if we graph that, we would be looking at the up and down, the difference, okay? And then we have x2 minus x1, okay? And that would be our run, okay? So in this case for number 1, y2 is negative 20. Minus y1, which is negative 3. And our run, x2, 19, minus x1, which is 20. And then, so that simplifies to, so basically we're adding 3, so negative 17. And then over negative 1. Which is just equal to 17. So that means that our slope is a17, okay? Same idea when we get to the next one. I'll just show another example. Again, it doesn't matter which point I label as 1 and 2. So I'm going to just label this x1, y1, x2, y2, okay? So for number 2. So rise over run, y2 minus y1 is going to be, what, 9 minus 9, so it has a slope of 0. I can see that right away. I wouldn't have to go any further because that's a slope of 0, there's no change. So that's just 0. It doesn't matter what our denominator is, it's not going to be 0. So the slope is 0. So D is our answer. I could go further, but I have my answer because it just doesn't really matter here.